Welcome back. In our last lesson, we saw that while decision trees are intuitive, they have a major flaw: they love to overfit. Today, we'll learn about the model that solves this problem brilliantly, one of the most powerful algorithms in machine learning, the random forest. So what is a random forest? It's what's known as an ensemble model. The core idea is simple. Instead of building one big, perfect decision tree, we build hundreds of smaller, slightly different trees. Then, to make a prediction, we let all the trees vote, and the majority wins. This is the wisdom of the crowd principle applied to machine learning. The entire point of this is to solve the overfitting problem. A single decision tree has high variance. It can be unstable and will change dramatically if the data changes slightly. But when we average the predictions of hundreds of diverse trees, the individual errors and quirks of each tree get smoothed out, leading to a much more robust and accurate model. The magic of the random forest comes from the two ways it injects randomness into the process. First is a technique called bagging. This means each individual tree is trained on a slightly different, random sample of the original data. The second is feature randomness. At every single split point in a tree, the algorithm is only allowed to consider a random subset of the total features. This ensures that all the trees in our forest are different from one another. Once the forest is trained, making a new prediction is a simple democratic process. You show the new data point to every tree in the forest. Each tree makes its own individual prediction. For a classification problem, the final prediction is simply the class that got the most votes. For a regression problem, it's the average of all the individual predictions. This combination of features makes random forest an absolute powerhouse. It's one of the best, off-the-shelf, algorithms you can use. It's highly accurate, doesn't overfit easily, and works well without a lot of complicated tuning. For many standard classification and regression tasks, it's a go-to starting point. And now you understand the power of ensemble learning. You've seen how combining many simple models can create one incredibly powerful and robust model. But this isn't the only advanced algorithm out there. In our next lesson, we will explore a completely different way of thinking about classification with a model that tries to find the best dividing line between classes, the support vector machine.